Hi, and welcome back to Chem Grinds. In the previous videos, we have discussed how we can calculate the concentrations of solutions in grams per liter or in moles per liter. Those are the two most common ways of expressing or finding concentration. However, if we think about grams per liter for a second, when we think about how much a gram seems like a small amount, and it is a small amount compared to many things. So a gram is small compared to a kilogram, for example, or a gram is small compared to a ton, but there are measurements smaller than a gram. And sometimes when we're talking about an incredibly tiny amount of solute, a gram is not a particularly useful unit to measure it in because we can have a tiny amount of grams. So grams per liter is not always that useful of a measurement. So we're going to talk about another measurement today, which is much less common than grams per liter or moles per liter. And we're going to start by looking at an example to illustrate it. So here I am just drawing an area. So I'm going to draw it in the box, and we're going to say that this here is the ocean. Okay. Now we've all heard of this idea that sharks can smell blood from a long way away. Some people say sharks can smell blood, one drop of blood, from miles away. Now that's kind of what we call hyperbole. And what that means is it's kind of an exaggeration. They can't smell one drop of blood from miles and miles away. However, when you consider if we were to place a shark here, for example, here I'm drawing a shark, really badly drawn shark, but you get the idea. If we were to think about the shark and how close he is to us, it might seem like he's close, but you have to remember how big the ocean is and how many liters of water there are there. So if you were to cut yourself and drops of your blood were to fall into the water here, these drops represent very tiny amounts of solute in quite a massive amount of solution. So what we're talking about today, this way of measuring things, is useful when we're talking about very tiny amounts of solute, tiny amount for every liter of water, for every 1 liter. So if we were to consider this here as being a liter, this little square, there is one molecule or one tiny part of blood there. It's not even a full drop because there's only one drop altogether. And look how spread out it is. There's only one tiny amount. It's nowhere near a gram in a liter of water. So it's not really a helpful measurement here to think about grams per liter. Grams per liter here is not very useful because a gram is quite a big amount compared to just talking about a couple of molecules in a liter of water. So sharks can smell or they can smell or taste. I don't know quite what the correct phrase is. Do they smell or do they taste it? But they can smell very tiny concentrations of blood. So blood, even if there's only 1 or 2 tiny parts for every liter, they can smell that. Now they can't smell it from miles and miles and miles away. If we put the shark over here, well, there's definitely not going to be any blood here. If the person here is bleeding, their blood is going to spread out for sure. So these little drops of blood, these molecules are going to spread out over a bigger distance, but they're never going to spread to miles away, right? So I think that's kind of an exaggeration. So if they're in the area though, they can smell it, even though it might only be 1 or 2 or 3 molecules of blood in a massive amount of water, they can smell or taste that. So it's just an exaggeration to say they can smell it from miles away, but they can smell very low concentrations of blood in water. So if grams per liter isn't a useful measurement of doing it, well, what is a better way of doing it? Well, a better way of doing it is to take a smaller unit of mass. Instead of talking about grams, we can talk about milligrams. Okay, and the relationship here is that 1 gram, is that for every 1 gram, we have 1,000 milligrams. So that's the relationship. I want to think about that. Or there are 1,000 milligrams for every 1 gram. So that's our relationship between grams and milligrams. And we can then think about milligrams per liter instead of grams per liter. So this is a much smaller measurement of solute for every liter. So this is more useful when we're dealing with tiny concentrations, excuse me. Now, when we talk about milligrams per liter, there's another way that this gets known. There's another way that this is known, where 1 milligram per liter is equal to something called 1 part per million. Part per million, or ppm for short, 1 ppm. So ppms are equivalent to milligrams per liter. So milligrams per liter equals to ppm. So however many milligrams per liter you have, that will be the same amount of parts per million. And sometimes we get problems or questions where we have to find the concentration in ppms, parts per million. And you have to know that that's the equivalent of milligrams per liter. So if you have grams per liter, you have to turn it into milligrams per liter, and that will give you parts per million. Okay, so big picture again, what is this? This is a measurement for measuring concentration of very low concentrated solutions. For example, blood spreading out into an ocean of water. You've got tiny concentrations. So in this case, it's not helpful to measure the solute in grams. There's just not very much of it. So instead, we measure it in milligrams, a much tinier measurement of mass. The relationship here is 1 gram is equal to 1,000 milligrams, or 1,000 milligrams for every 1 gram. That's going to be important when we do some calculations in a second. All right, before we go and practice some problems, the first thing that I would like you to do is to try and make sure that everybody understands how to convert between grams and milligrams. So say we have 5 milligrams, okay? What I would like to know is, what is that in grams? Okay, so we're going to convert by some conversion factor, like we always do using unit analysis, where we create an answer in grams. Okay, all right. So what I would like you to do is, I think you guys, without me doing this, practicing this, I think we've done enough of these type of things now that some of you should be able to pause the video and have a go at this now. Do that now, please. All right, if you weren't able to, I'm going to help you set up the units. We need to go from milligrams to grams. Okay, so we want milligrams to cancel out and not be in our answer. So we put it in the denominator of the conversion factor. Now milligrams cancels with milligrams, and that means that grams is in the numerator. The next thing is, what's the relationship in numbers between grams and milligrams? You should definitely be able to do this now. Pause the video, do it now. Okay, what you should have said is that for every 1 gram, there are 1,000 milligrams. Sorry, 1,000 milligrams. All right, and now you've got your sum. You're ready to convert to grams. Pause the video, do that now. 0.005 grams is what you got. So 5 milligrams is 0.005 grams. Right, you're ready to do some practice questions with this. If you want to have a quick read and just recap for yourself, you can read here about what parts per million are. Pause the video, do that now if you need to. And then we're doing questions 10 and 11, please. So in 10, we've got to go milligrams to grams. And then in 11, you've got to go grams to milligrams. Should be pretty straightforward, I think. Okay, good. So hopefully those were no problem. Don't think you should need too much help with those. We will go through them the next day in class. The next thing is, we want to express some problems in the form of milligrams per liter. So let's go and again model for you how we can do one of these. So the first thing we've got to think about is, what direction are we going? I always like to plan it out. Say if we're given grams per liter, most of these problems are going to give you grams per liter, and we have to convert to parts per million. Now, what do parts per million mean? It means milligrams per liter, so in ppm. So that's how I plan out my problems. I'm going from grams per liter to milligrams per liter. All right. So let's say, for example, we were asked to convert 245 grams to grams per liter to milligrams per liter. So the first thing I do is start by writing down what I have. 245 grams per 1 liter. That's what it gave me in the question. And it asked me to go to milligrams per liter. So I know I'm going to have to multiply by a conversion factor. And that's got to give me milligrams per liter in my answer. So milligrams per liter will look like this: milligrams on the top, liters on the bottom. Okay, so now I need to think about my units. You'll do my unit analysis. I've got liters in the denominator on the left, and I've got liters in the denominator on the right. That's good. So I don't want any liters to cancel out. So I'm not putting liters in my conversion factor. I've got grams, though, in my numerator, and I've got milligrams in my numerator over here. So that's no good. I need to remove grams. So to make it remove, I need to put it here. So I'm going to put grams down here. And then I need to create milligrams in the numerator. So that has to be here. So this here is going to have to be milligrams. All right, so what's my relationship between grams per liter and milligrams per liter? Should be 1,000 milligrams for every 1 gram. So then you're going to get your calculator, plug in the numbers, and you should be left with, remember that the red ones, the 2 grams cancel out, and I'm left with milligrams over liters, which is what I have over here. So it's all good. Some looks good so far. I'm getting rid of, sorry, those lines I've just drawn because they make a mess. And I'm getting my calculator out and I'm doing this. I'm going to get 245,000 milligrams in every 1 liter. And that is equivalent of 245,000 ppm. And that's how I write my answer. So that there will be my final answer. That's how you do it. Okay. So now that we've done one of them, let's make sure then that you should be able to do all of these, I think. Yeah, so it says here, express each of the following in terms of milligrams per liter, and then please write them as ppms then, because that's the practice to get into. All right, because we do need to link together the idea that milligrams per liter and ppms are the same thing. All right, so pause the video and have a go at them. All right, guys, part A, sorry, we've actually done that already. That was the example that I did. And think that most of them should have been pretty straightforward, with the exception of this one, being careful because we didn't have it in liters, okay? And we had to convert this to liters first before we continued on. So maybe we'll do that one just as I think that's the only one that's going to really. Oh yeah, sorry. And then this one we were given moles per liter, and we had to go first to grams per liter and then to milligrams per liter. So if you didn't notice them things, maybe pause the video and have another look at them, another go at them now, doing them. All right, so let's maybe talk about D here and what D looks like. Okay, so let's write down what we have first of all. We have 600 grams per 500 cm cubed. Okay, now plan it out. What am I doing? I'm going from grams per cm cubed, and I'm going to go to grams per liter. And then a second conversion, I'm going to go from grams, sorry, I'm going to go to milligrams per liter. All right, which is the same as ppms. So now that I've helped you plan it, if you weren't able to do it, maybe you can have a go at that now. Pause the video and do it now. Okay, so first thing we're going to do is we're going to do this conversion. Grams per centimeter cubed to grams per liter. Done this before in the previous skills that we learned, so this should be pretty straightforward, I'm hoping. So what do I want? I want to multiply it by a conversion factor, which gives me grams, sorry, which gives me a certain amount of grams per liter in my answer. Okay, so I need centimeters cubed to be gone. So I'm going to cancel that by putting centimeters cubed up top. And I need liters to appear in the denominator. So I'm putting liters here. That's all you have to do. What's the relationship between centimeters cubed and liters? It's 1,000 centimeters cubed for every 1 liter. Okay, and going to do that now. So give me a second, get my calculator. Again, if you haven't got this done, you should be trying to race ahead of me now and get this done. So you get the practice of doing at least that much by yourself. Okay, so what I got was 1,200 grams per 1 liter. Okay, now I'm going to do part 2 by going from grams per liter to milligrams per liter. I'm going to do it on the second line. I'm taking this here. You could just continue it here. No, maybe I'll continue it here. It's fine. So we're going to go from grams per liter, and we're going to convert it again so that I end up with milligrams per liter. Okay, so what do I need? I need liters to stay the same, so that's fine. I need grams to disappear, so I need grams in the denominator here, so it cancels out, and that means I need milligrams in the numerator. So I've got 1,000 milligrams for every 1 gram. I'm going to stick that into my calculator. This number is getting bigger. At 1.2 million. So 1,200,000. So 1 0.2 million, or you might have got 1.2 by 10 to the 6 milligrams per liter, or ppm. Right, so well done. If you got that all by yourself, well done. If you got it in steps as we went along, pretty good as well. We do need to build up to you guys being able to do that by yourself. All right, let's look at E now. Maybe we'll go through this, guys. If you're pretty confident you got this right, you got this one right, and you're sure you got this one right, you can turn it off or fast forward to the answer if you like. But if you're not sure, then you need to be watching. Okay, so plan it out first. Pause the video, write down what's the plan. What are we doing? Okay, so hopefully you said we're going to go from moles per liter to grams per liter, and then from grams per liter to milligrams per liter. If you didn't know how to do it, and now I've showed you, maybe you can pause the video and do that now, please. All right, so first thing we need to know is we need to write down what we have. We've got 0.1 mole per 1 liter, and we need to go to grams per liter. Okay, so I'm going to have a conversion factor that gives me some amount of grams per liter in the answer. All right, I've got liters already in the numerator, in the denominator. I've got liters here, so that's good. Okay, what I've got though is I've got grams in the numerator, which means that my grams needs to appear in the numerator here. So my grams going to be here, and I need moles to disappear. So I'll put moles in the denominator like that. So what's my relationship then between grams and moles? Well, of course, that depends on the substance. The substance is NaOH. So for every 1 mole, I'm going to have to find the mass of that substance. So 23 for the sodium atom, plus 16 for the oxygen atom, plus 1 for the hydrogen atom. Oh, sorry, my screen seems to be freezing here. So I might have to pause it for 1 second. Sorry. So I've got 23 for the oxygen atom, plus 16 for the oxygen atom. Sorry, 23 for the sodium atom, plus 16 for the oxygen atom, plus 1 for the hydrogen atom. So let's get my amount of grams for every mole. So I'm going to stick that on my calculator now, and that'll give me my grams per liter. So 0.1 over 1 times by 40 over 1 gives me 4 grams in every liter. All right, so that's the first conversion done, moles per liter to grams per liter. Now I need to go from grams per liter to milligrams per liter. So I'm going to go another conversion factor like this, and I'm going to make sure then that I've got milligrams per liter as my answer. All right, so I've already got liters in the denominator, so that's good. I need to get milligrams in the numerator. So milligrams has to appear in the numerator here, and grams has to get cancelled with those grams. I have 1,000 milligrams for every 1 gram. So I'm going to go ahead and finish this off now. It gives me 4,000 milligrams for every 1 liter, which is 4,000 ppm. All right, so that's it, guys. Most of the other ones should have been pretty easy. I just spotted D and E were a little bit harder, had a few extra steps. If you got them both right by yourself, absolutely brilliantly well done. You definitely have the hang of it if you got those two. And these are some of the trickiest little calculations, because the things people don't spend very long on, and the things that, you know, they come up on the exam, people haven't practiced them properly. So you have got lots of practice on it here. If you can do all these, you can definitely do anything that comes up on the exam. So that's good, guys. Well done. We'll see you in the next video.